Don't tell me the moon is shining. Show me the glint of light on broken glass. There, that's my best Chekhov. I actually have no idea what Chekhov sounds like. You probably don't either. So for all you know, that could have been spot on. Well, what is spot on is his message to other writers about the value of writing descriptively. There's a rule of fiction, a real simple rule, which is show, don't tell. It's a rule that underscores the importance of writing descriptively, and that being part of the art of good fiction. Well, in this presentation, you're going to be learning about different types of instructional graphics. And these are things that you can use to improve an instructional experience. And so for this presentation, we have a general rule, which is to show and tell. Some of the best instructional experiences involve information in which things are shown as well as told. And it's the showing that this presentation addresses, showing in the form of visual representations or images and graphics. So this presentation is about different types of graphics, and once you have a good understanding of this, then subsequent presentations will address what types of graphics best support the types of learning that you want to affect as an educator. The first category of graphics to be discussed are decorative graphics. Now, these are graphics that add aesthetic appeal, humor, or attention-getting strategies to instructional materials. The art on the cover of a book might be very decorative. Cartoons dispersed through a dry text might be decorative. Here you see a probably familiar decorative graphic that is presented on the homepage of Wikipedia. It adds aesthetic to the homepage. It speaks to the general sort of idea of Wikipedia in some ways, but it doesn't connect directly to specific information. Here you see another example of a decorative graphic. This cute little round illustrated owl on top of a book. Again, this adds aesthetic appeal. It's attention getting. It could be used in many different situations to sort of just make the information presentation overall more appealing to look at. Not necessarily supporting something specific related to the instruction, but it is categorized. And finally, the last example of a decorative graphic would be something that you might find in a math textbook. Here is a whimsical illustrated number 3. Again, this adds some aesthetic appeal. It gains attention. You might not use a graphic like this if you're trying to use something to support the learning of how to write a number 3. So in this case, it was used for decorative purposes only, but again, can be very valuable in an instructional experience. The next category of instructional graphics are representational, and these are graphics that depict an object in realistic fashion. Now, you might not find a realistic looking illustration of the human heart communicated in an elementary math textbook, but you've probably seen graphics like these in science textbooks. They're very common, and they serve a number of important instructional roles within the information presentation of something like a science text. And this is just a common good example of a representational graphic that depicts an object in realistic fashion. Another example of representational graphics that you might see in a math text is presented in this diagram. You'll notice that in the panel on the left, there are representational depictions of wooden sticks and buckets. That to be contrasted with the representations in the middle panel, which show sort of schematic representations of things that could be sticks and could be buckets. Again, in contrast with no graphics in the panel to the right. Now, if this information as part of the instruction was trying to communicate how to solve a particular word problem that involved wooden sticks and buckets, then it's quite possible that using representational graphics for some learners could be much more beneficial than presenting things in more abstract fashion. So once again, an example of presenting objects in realistic fashion are representational graphics. And finally, this example of representational graphics depicts 3 realistic looking apples. And again, if you were communicating information about the old classic math problem for elementary kids regarding the amount of apples that you are in some ways manipulating, then there might be a good reason to represent them in a more realistic fashion. Again, for some learners, they might be able to better understand the verbal information or the text that's being presented. The next category of graphics are called mnemonics, and you're probably familiar with these in your life in terms of verbal mnemonics, but these are visual depictions that provide retrieval cues for factual information. So in this case, if you wanted somebody to remember what mélange means, what its definition is, you might represent a melon and an orange mixed together as part of the word. Here's a very common mnemonic used in math to try to help students remember the order of operations. Again, this is used to provide retrieval cues for factual information, in this case, the information being, well, what order do I need to do things in when I'm given equations that have various factors. So PEMDAS is a mnemonic that is often used. And finally, for mnemonics, it could be something as whimsical as a visual representation along with a little phrase, the man with the big nose, to help students remember how to, the order of how to, or what to do when you're multiplying 2 of these equations or factors together. The next category of graphics are organizational, and these are graphics that show qualitative relationships among content. In this example, we see a graphic representation of the qualities of what is considered the left brain processes versus the qualities of a right brain processes. And just visually, you can see a difference that would help support a general conceptual understanding of the differences between those characteristics. Another example of organizational graphics used in math are Venn diagrams. Again, 2 good examples representing a qualitative relationship among content. Another category of graphics related to the previous are relational graphics. Now, these are graphics that show quantitative relationships among 2 or more variables. And perhaps the most common type of relational graphic is some type of actual graph. In this case, a bar graph that depicts the relationship between 2 variables, in this case, temperature and date. Again, graphs are often used to show quantitative relationships, and when that relationship is characterized as the relationship between amounts of things based on a scale of 100, that's a good example of a pie chart, and a pie chart is a great example of relational graphics. Another category of graphics are transformational. These are graphics that show changes in objects over time or space. Now, the water cycle is probably a concept that most of you learned about in one of your sciences, middle school, junior high school, who knows, maybe even college. But it's a classic example of a transformational graphic that shows changes in water, well, over time and space in this graphic. Another page out of the science text would be the photosynthetic process or respiration or some other important biochemical process that you wanted to depict. In this case, it's a another classic example of a transformational graphic. Even some basic diagrams used to help clarify the process and the information presented in a math word problem can be considered transformational. Here's a strip diagram that represents the amount of money that Shantae had before spending a certain amount of it on a book, and it graphically represents a change over time, a change in the amount of money that Shantae had after a certain event occurred. So this is, again, a really good example of a transformational graphic. And finally, the last category to discuss are interpretive graphics, and these are graphics that are used to illustrate a theory or a principle. Now, again, I know that the model of an atom is not something that would likely show up in most math textbooks, but it's a good example of an interpretive graphic that you're probably very familiar with, because atomic theory can be very abstract, but it's almost always communicated with some type of very simple, in this case, perhaps oversimplified representation of that theory. A good example that might show up in a math text is a graphic an interpretive graphic that illustrates the Pythagorean theorem by, in this case, depicting that if you square A, which is one side of the right triangle, and you square the side B, which is the other side of a right triangle, that you put A and B together, and that will take up the same amount of space as squaring C, the hypotenuse. Now, this would be a graphic that you probably would want to use with a transformational graphic to show that A and B, when you cut them all apart, really do fit inside of C. But again, this is just a good example of an interpretive graphic, one of the different types that are used to help support the learning of certain types of skills and certain types of information in instruction. And from here, you're going to move on to learn more about how different types of graphics can be used to support the learning of different types of skills and different types of knowledge.